In the previous video, I have talked about knife-based classifier. I have shared the link also here. So in this video, let's discuss spam classifier using knife-based. First, quickly see few normal emails and spam emails. Here, first one is a spam email. The subject is congratulations, you have won a free gift card. And it says, dear user, you have been selected to receive a $500 gift card. Check the link below to claim. Hurry, the offer expires in 24 hours. Free, win urgent. This is definitely a spam email. Next one, urgent, your account will be suspended. Your bank account requires immediate verification. Failure to act may result in account termination. Verify here. Urgent action required. This also looks like a spam email. Next one, meeting agenda for 15th October. Hi team, please find attached the agenda for tomorrow's meeting. Let me know if you want to add anything. So this doesn't look like a spam email. This is a normal email. Next one, your order has been shipped. Your order number this has been shipped. Track your package here. Thank you for shopping with us. This is also a normal email. Now, just looking at the emails, we can tell this is a spam email and this is a not spam email, right? But how a machine learning model can can classify normal email and spam email? Consider the presence or absence of some words can influence the mail being a normal one or a spam. Now, of course, different types of mail data set will have different types of word. A corporate email and an e-commerce email will not have the similar words, right? But even in that case, for our data set, right, for the whatever mails we just saw, the words like free, own, gift, urgent, if those types of words are present, the probability of being it a spam is more. If we have meeting, order, shipped, agenda, this type of words, then the probability of not being a spam is more. So, of course, different types of mail data set will have different types of words. But we'll just assume different words will influence the mail being a normal one or a spam one. Now, knife-based considers the mail or the document as a bag of words, like a collection of words. Also, it assumes the presence of each word is independent in the document. So that's why we are calling it knife-based classifier, right? But this is not entirely true, right? Different words might be related in a document. Consider this sentence only here. Click the link to claim your prize. Here, click and link, these are related, right? What to click on? Click the link. Click and link is related. Claim your prize. Claim and prize also related. Your prize. Whose prize? Your prize. Your and prize also is related. So there will be word relations in a sentence or in a raw mail document. But knife-based doesn't care about any word-to-word relations. No syntax, no dependency structure, no word order is considered for doing this knife-based classification. Yet, it still performs surprisingly well for spam classification. Now, consider the mail document that has these words W1, W2, W3 till WC. These are called bag of words. So if we have a label dataset D, x1, y1 till xn, yn, where xi's are the mail, yi's are the output class like spam or not spam. Also consider our vocabulary has D number of words. So we can represent our mail in a D cross 1 vector or D dimensional vector. So xi is a D dimensional vector and yi is 1 or minus 1. 1 for being a spam, minus 1 for being a not spam. Let's assume that. Now each xi can be represented as a D-dimensional vector. Now what is nik? Any NIK is the number of times the kth word occurred in the ith mail. So we assume that vocabulary has d number of words, right? So for the any kth words, consider the second word in the vocabulary occurred this many times in this mail, xi mail. So number of times the kth word occurred in the ith mail. So we have x1, x2 till xn, this n mails, and y1, y2 till yn, n labels, either spam or not spam. Each mail, each xi mail can be represented in d dimension. So there are d words in the vocabulary. So n11 represents how many times the first word in the vocabulary occurred in the first mail. N21 is how many times the first word occurred for this second mail. N2D means how many times the dth word in the vocabulary occurred for the second mail, and so on. Now next, for a new mail X, we need to classify it as either spam or not spam. We need to calculate probability of output class Y given input X. So if you have seen my previous video on naive Bayes, you will understand what notations I am using here. So from training dataset, we already will have the prior probabilities like probability of input X given output class Y, probability of output class Y. So in our mail dataset, the training dataset will have, there will have the probability of the output class Y, like probability of spam in the training dataset, probability of not spam, that also we can calculate from our training dataset. And for a particular output class Y, spam or not spam, the probability of the input class, that also we can calculate from our dataset, training dataset. Using Bayes theorem, then we can calculate our desired probability. Probability of output class Y given input X using Bayes theorem. So this is the Bayes theorem. Probability of input X given output class Y times probability of output class Y divided by probability of input class X, input X. Now, this probability of input X is not changing, right? So, probability of output class Y given input X will be proportional to this numerator part. Now, if there are two, here in this case we have two classes, spam and not spam, right? For both of the output classes, we will calculate this probability. Whichever probability will be higher, that will be our output class. Next, let's see this with some example. Try to understand with some examples. Let's say there are 3 spam emails. I have taken very small, minimal, simple emails for our calculations here. So, claim cash now, win cash reward, money reward now. So, these are few spam emails. And few two non-spam emails also I have, like account reward money updated, cash received now. These two are not spam emails. So there are total 5 emails, 3 spam emails, 2 not spam emails. So that means probability of spam is 0.6, 60% of the emails are spam, and probability of not spam is 0.4, 40% of the emails are not spam. Also consider, we'll just focus on these 4 words, cash, reward, now, money. Other words I am ignoring here. So there are only 4 words in my vocabulary now. So each mail can be represented as a d-dimensional, as a 4-dimensional vector. For the first mail, you see claim cash now. How many times cash occurred? 1 time. How many times reward occurred? 0 times. How many times now occurred? 1 time. How many times money occurred? 0 times. For the second one, win cash reward. How many times cash occurred? 1. How many times reward occurred? 1. How many times now and money occurred? 0 times. So in this way, we'll just convert this raw text emails into this vectors. This is number vectors. For not spam emails also, I have converted them into vectors. Now, also just sum this up. This is for spam. How many times this vocabulary words occurred in the whole spam class? Cache occurred one time, two times. Two times cache occurred for spam class. Also, you can just sum this up, right? So there are these three are for spam. So 1 plus 1, there are only 2 cache. Reward 1 plus 1, 2. Now 1 plus 1, 2. Money only 1. So you see now occurred 2 times. Reward occurs 2 times. And cash also occurred 2 times. Only money occurred 1 time in class spam. Similarly, for not spam, I'll calculate cash occurred only 1 time, reward 1 time, now 1 time, money 1 time. So from this vectors also we can get that. So there are total 7 words in the spam class and total 4 words in the not spam class, considering only these 4 words in the vocabulary. Now next we have to classify this test email. The test email is cash reward now. So this test email we have to classify whether this is a spam or not spam. What you will do, we will calculate the probability of spam given this test email, and also we will calculate the probability of not spam given X. Whichever probability will be higher, that will be our decision. Now, using Bayes theorem, it will be probability of X given spam times probability of spam divided by probability of X. What is this probability of X given spam? X is basically this test email, right? Cash, reward and now. So it's basically probability of cash given spam times probability of reward given spam times probability of now given spam times probability of this spam. Now, as Bayes considers these words are not related, that's why the probability of cash reward now given spam can be written as probability of cash given spam times probability of reward given spam times probability of now given spam. These are independent. These words are independent. Now, what is this probability of X, this the denominator part, this is not changing, right? So we can say probability of spam given X is proportional to this numerator. Now let's calculate the probabilities. Probability of cash given spam. How many times cash occurred in spam? 2 times out of 7 times. How many times reward have occurred in spam? 2 times out of 7 times. So let's just place the numbers. 2 by 7 times 2 by 7 times 2 by 7 times this probability of spam is 0.6. We get this number. So probability of spam given this test email is proportional to this. Next, probability of not spam given X. Using Bayes theorem, we will calculate as probability of X given not spam times probability of not spam divided by probability of X. So we'll just again expand this. We'll get probability of cash given not spam times probability of reward given not spam times probability of now given not spam times probability of not spam. And this probability of not spam given X is proportional to this whole numerator thing. Now, how many times cash occurred in not spam class? 1 times out of 4 times. How many times reward occurred in the not spam class? 1 time. So like this, we just place the numbers 1 by 4 times 1 by 4 times 1 by 4 into this 0.4 is the probability of not spam, and we get this number. So probability of not spam for given this test email is proportional to this number. So for this test email, we got probability of spam given x is proportional to this. Probability of not spam given x is proportional to this. So of course this is higher. So we can say this test email is a spam. Next, Laplace smoothing. Why we need that? This is very important point here, Laplace smoothing. Without Laplace smoothing, one unseen word can destroy the entire probability. So let's understand that with an example. So the previous example we had was these 3 spam emails and 2 not spam emails. We had this 4 focus words. Now we got this spam probability of spam given x and probability of not spam given x, and from that we decided the class. Now let's remove this money word from this first not spam email. Instead of account reward money updated, we will just take account reward updated. I just updated this not spam emails here. Let's see how the calculation goes. So other numbers will remain same, but in the not spam, for the not spam class, we see there is this money occurred 0 times, right? Because we don't have any money for not spam class, right? So let's see how now the test email is money reward now. Okay, so probability of spam given x will calculate and probability of not spam given x will calculate. Probability of spam given x we can calculate using Bayes theorem. We will expand just like how we did earlier, and this probability of spam given x will be proportional to this numerator thing. We'll just place the probabilities here. We get this number 0.006997. We are good here. Now let's calculate the probability of not spam given x for this test mail. Money reward now. Earlier we had the test mail cash reward now. Now we have changed the test mail to money reward now. And this money is not present for the not spam class. Now let's see how the calculation goes. Probability of not spam given x is probability of x given not spam times probability of not spam divided by probability of x. Let's expand this and we get probability of not spam given x is proportional to this numerator thing. Probability of money given not spam times probability of reward given not spam times probability of now given not spam times probability of this spam, not spam. Now, what is probability of money given not spam? How many times money occurred in this not spam class? 0 times, right? So let's place the numbers. So we get 0 times whatever it is, whatever numbers we get after that. So the probability of not spam given x is 0. Just because in the test email we have this word money which is not present for this particular class, not spam class. Right? So for the spam class, what we got? We got this is the probability, and for the not spam class, we got 0. These two probabilities are not even adding up to 1. So these probabilities are not correct. So that's where Laplace smoothing comes into picture. What Laplace smoothing does is it prevents probability from becoming 0 when a word doesn't appear in the training data for a class. Just that's what happened here. In the test email we had money, but for the not spam class we didn't have the money, right? So what Laplace smoothing does is it changes the probability calculation, the way we are calculating the probability. Earlier we are taking word count divided by total number of words, right? Word counts divided by the total number of words. Instead of that, what it does is word count plus 1 divided by total words plus vocabulary size. And just because it is adding plus 1, this makes sure that nothing becomes 0. Now next we will calculate the probabilities with Laplace smoothing. So here probability of spam given x will be calculating using Laplace smoothing. So of course this probability of spam given x is proportional to these things, probability of money given spam times probability of reward given spam times probability of now given spam times probability of spam. So how many times money occurred in spam? One time. So and the total words is 7. So we'll take 1 plus 1 divided by 7 plus 4. 4 is the vocabulary size. How many times reward occurred? 2 times. 2 plus 1 divided by 7 plus 4. How many times now occurred? 2 times. 2 plus 1 divided by 7 plus 4. And probability of spam is 0.6. So we get this number. Next, for the not spam, probability of not spam given x using Bayes theorem and Laplace smoothing. We get this probability of not spam given x is proportional to this probability of money given not spam times probability of reward given not spam times probability of now given not spam times probability of not spam. So how many times money occurred in not spam class? 0 times, right? We'll get 0 plus 1 divided by 3 plus 4. 4 is the number of vocabulary size and 3 is the total words in the class, in the not spam class. Reward occurred one time, 1 plus 1 divided by 3 plus 4. Now occurred one time, so 1 plus 1 divided by 3 plus 4 and times 0.4. Then we get this number. So this is not 0. Just because we added 1 here, we got saved here and we got the probability. So this is the for this test email with Laplace smoothing we got both the probabilities for being spam or not spam, and we see of course the here this is higher probability of spam given x, this is higher, so this is also this test email this is also a spam. Now, knife base can be used for many other document classification tasks as well, not just spam detection, of course. Sentiment analysis, text classification, language detection, news categorization, customer support ticket classification, etc. For many other applications, we can use knife base. So we can say naive base is naive because it doesn't take care, it doesn't consider the word relations or any other input relations in the data set, but still it still performs surprisingly well for many applications.